Let's review how to do some medication calculations. We're going to begin with conversions. Now let's take a look at how we get from kilograms to micrograms. Kilograms are the bigger value but smaller number, which leads to grams, milligrams, and micrograms. Now, what we want to do to get the kilograms to grams is multiply by 1,000. There are 1,000 grams in 1 kilogram, 1,000 milligrams in 1 gram, and 1,000 micrograms in 1 milligram. If we want to go the opposite direction, we would divide instead. So as we want to move from micrograms to milligrams, we would divide by 1,000. And from milligrams to grams, divide by 1,000. And from grams to kilograms, we would divide by 1,000. We can also look at this as moving the decimal place 3 places. Let's look at this problem. We want to get 500 milligrams equals how many grams? So if we look at the chart above, we want to take our milligrams up here and go to the left to grams. Okay, so we are going to move our decimal place to the left and divide by 1,000. So if we take our decimal here and we move it 1, 2, 3 places over, that gives us 0.5 grams. Okay, and if we did the math, if we want to divide by 1,000, we could take 500 and divide by 1,000 and we would still get 0.5 as our answer. Now let's go the other way. We want to take 3 grams equals how many milligrams? If we look at our chart, we're going to go from grams to milligrams. So we're going to move our decimal place 3 places to the right. We're basically multiplying 3 times 1,000. So we can take our 3, put our decimal place at the end, move it 1, 2, 3. Let's move that down so we can see it. 3 and 1, 2, 3, and that's 3 zeros in the holes. 3,000 milligrams. And you can divide it, multiply it. So we're going to take our 3 times 1,000, and that makes 3,000 milligrams. Now let's look at some weight conversions. 1 kilogram equals 2.2 pounds, and our conversion factor is going to be the 2.2. We're either going to divide or multiply by 2.2, deciding on which way we need to go. Now, if we want to go from pounds to kilograms, we're going to divide by 2.2. And if we want to go from kilograms to pounds, we're going to multiply by 2.2. So let's look at this problem. We want to take 43 pounds and convert that to kilograms. So to convert pounds to kilograms, we divide by 2.2. So if we divide 43 by 2.2, you would get 19.5 kilograms. So we usually always put a 10th decimal place on kilogram conversions. But what if you need to convert 43.3 pounds into pounds and ounces? Well, we have 16 ounces equals 1 pound, okay? So you're going to take your 0.3 here, 0.3, that's 0.3 of a pound. But we need to know how many ounces is that. So you're going to multiply that by your conversion factor here, which is 16, okay? And when you multiply that, that will give you 4.8 ounces. Okay, so 43 pounds and 0 4.8 ounces. 4.8. That's your ounces here, because this is an ounce and this is 0.3 pounds. Now, what if we need to take 43 pounds and 4 ounces and convert that into kilograms for maybe a weight-based conversion for medication administration? What you're going to do here is take your 4 ounces, 4 ounces, and you're going to divide it by 16, and that's going to give you your decimal point for your pounds. 0.25 pounds is how much this is. So now you have 43.25 pounds. Now you can take your whole pounds and ounces here in the decimal format, and you can divide by 2.2 in order to give you your kilograms. So when you divide that, you will end up with 19.7 kilograms. And that would be your answer for this right here, 19.7. So I basically had to take this 4 ounces and convert it into a decimal format so I could divide it appropriately. Now looking at the opposite, what if we need to convert kilograms to pounds? This time we're going to take our kilograms and multiply that by our conversion factor, 2.2, and we end up with 44 pounds even. So that would be our answer. Before we move any further, it is important that you memorize the conversion chart, and these are the most common ones that we will use all the time. So these are the ones that you have to memorize, and it includes also on here like milliliters per cup and ounces per cup, mLs per ounce, teaspoons, your metric conversions, weight conversions, and then also the micro drop for drop factor tubing is 60 drops per ml. So we'll be using that throughout. And the macro drops depends on what drop factor is given to you. And let's move on to doing some dimensional analysis and applying these conversion factors in practice problems. Now, let's move into dimensional analysis. Remember the acronym WACO, okay? This is going to help you set up your problem correctly. That way, you will have a no-fail process of dimensional analysis. Well, you will always get the right answer if you set it up correctly. The first one is W for want. We want what we want to give. What is your end goal? Are you going to give milliliters? You're going to give tablets? Are you going to give drops per minute, milliliters per hour? What are you going to be giving the patient? What do you want to give? Okay. What is available? What's the supply? How does it come? C's for conversions. Is there any conversions to do? Do we need to convert micrograms to milligrams, grams to milligrams? What conversions do you need to get you where you want to go? O is for ordered. What is ordered by the doctor? So what is the total that you're ordered to give? Okay, so let's take this practice problem. We have an order of 0.3 milligrams of medicine, PO, and available you have 150 microgram tablets. How many tabs do you give? Well, if I'm going by the acronym WACO, what do I want to give? I want to give tablets. Tabs is what I want to give. So I'm going to write that down here. Tabs. I want tabs, okay? And setting up my problem, I know that I need to put tablets up here because what is on top is what you want to give, okay? So I want tablets. Now, what is my available? I have tablets available right here. Here's my supply. I have 1 tab equals, and it goes with 150 micrograms. Okay, now I need to see what do I have any conversions to do? Well, this is in micrograms, and my order says zero point 0.3 milligrams, so that's not the same. I'm going to have to convert that. So what I need to do next is take my micrograms. I'm going to have to put the micrograms up here because I'm going to have to be able to cross these out. So I want to go to milligrams. So I know that there is 1,000 micrograms to 1 milligram. And I know that because I've memorized the conversions, okay? Now, am I done with this problem? No, because now I need to be able to cross out milligrams because I want tablets only. So I'm going to have to put milligrams up here so I can cross it out. Now, what's ordered? I have 0.3 milligrams. And there you go. Let me change this color here. Can I cross everything out? Yes, I'm left with just tabs, which is what I want to give. Now we're going to multiply across. So 0.3 times 1,000 is 300. And on the bottom, 150 times 1, 150. And when you divide that, it equals 2. So 2 tabs. I'm going to give 2 tablets of the 150 microgram tablets, which will equal my order of 0.3 milligrams. Now let's take a look at this problem. I have 15 milligrams of medication ordered PO by mouth. Available is 30 milligram tablets. How many tabs do you give? Okay, well, let's start with what do I want to give? I want to give tabs. Going on top. Okay, tabs on top. And what do I have available? I have 30 milligram tablets. So each one tab is 30 milligrams. Do I have any conversions to do? No, because both of them are in milligrams. So now what is ordered? I have ordered 15 milligrams to give. Okay, I have finished my Waco. Can I cross everything out? Yep, and I'm left with just tabs. So if I did my math, 15 divided by 30, I'm going to give 0.5 tabs, which is a half a tab. Okay,